Okay, we're going to do graphing linear equations, and I explained to my classes how this is going to be kind of a long video, so you may want to break it up into a couple of nights or 3 nights, whatever you want to do to get it all done, but it does need to be done by Friday because Friday in class we will be graphing linear equations. So you should have your composition book open, and we are going to start with the blue foldable that you put in first. If you'll look there, at the top it says slope-intercept form. Then it has the equation that's slope-intercept form, y equals mx plus b. We have learned that m represents our slope, so make sure you label that m is slope. We've also learned that b represents our y-intercept, so also label b as the y-intercept. You'll see that on your foldable we have the equation y equals 2/3 x minus 2. And this is in slope-intercept form. Step 1, you need to write this in your foldable. You have to determine what the y-intercept is from the equation and plot it on the coordinate plane. If you need to pause the video to get that written down, please do so now. So if we look at our equation, we can see that our y-intercept is -2. Since we have found what our y-intercept is, sorry about that, since we found what our y-intercept is, we can then plot it on the coordinate plane. So we know that our y-intercept is at -2, so we go to our y-axis and we go down to -2. And we plot a point. Okay? All right, so now let's go to step 2. For step 2, we need to identify the slope from our equation. So we know that our slope is 2/3. Okay? Remember that our slope is our rise over our run. So it says to use the slope to find more points starting at the y-intercept. So we go to our y-intercept. We are rising 2. So we go up 2 spaces. And then we are running 3. Since it's a positive 3, we go to the right 3. 1, 2, 3. So now we are at the point of 3, 0. Now from that point that we just plotted, we use our slope again. We rise 2, 1, 2, and we run 3. 1, 2, 3. Now we should be at the point of 6, 2. Okay, as long as you've got 3 points, that's all that really matters. And if you'll notice here, we have created our slope stair steps. All right. Okay, so now what we have to do, step 3, is to connect the points with a line and put arrows at the end. So we just draw a line to connect our points, and then we put arrows at the end because this line will continue in both directions. And that's how you graph an equation when it is in slope-intercept form. All right, now let's go over to your pink foldable. Or not. Let's go down to the bottom of your blue foldable. Next, we have to do what is called a point check. They are asking us, is the point 12, 6 on that line? So we had the equation of y equals 2/3 x minus 2. So in order for us to find out if 12, 6 is on the line, we know that 12 is our x coordinate and 6 is our y coordinate. So what we're going to do is we're going to plug in 12 for x and 6 for y into our equation. So y is 6. And then we're taking 2/3 times our x, which is 12. And so as a fraction, we're just going to make it as 12 over 1, because that's what a whole number is as a fraction. We put it over 1. All right, so now we look here and we have to do multiplication first. So if we look, we see that we have 2 times 12, which would give us 24, and 3 times 1 would give us 3. Well, what is 24 divided by 3? It equals 8. So now we have 6 equals 8 minus 2. What is 8 minus 2? 8 minus 2 is 6. Since 6 does equal 6, then yes, this point is on the line. Now let's do one more point check. Here we want to check to see if the point negative 1410 is on the line. So we do our equation. We had y equals 2/3 x minus 2. So in place of y, we put 10. We have 2/3 times a negative 14 over 1 minus 2. So now if we do 2/3 times a negative 14, we have to say 2 times negative 14. That would give us a negative 28. And then 3 times 1 would give us 3. If we wanted to figure out what that's really going to be equal to, because if we divide 28 by 3, take your calculator and do 28 divided by 3. Okay, that gives you 9.3 repeating. So basically, that really means 9 1/3. It's a negative 9 1/3, because if we did 3 into 28, it goes 9 times. That's 27 with 1 left over. That's how we get our 9 1/3. Okay? So we basically have 10 equals a negative 9 1/3 minus 2. You and I both know that a negative 9 1/3 minus 2 does not equal 10. Therefore, is this point on the line? No, it is not. Now let's go to your pink foldable. At the top of your pink foldable, it says standard form of a linear equation. In that box right underneath it, you need to have ax plus by equals c. This is the standard form of a linear equation. We talked about slope-intercept form on the other foldable. This one we're talking about standard form. So on method 1, you'll see right underneath method 1 there's a box. And in that box you need to write this right here where it says convert to y equals mx plus b by solving for y. Next, you'll see under method 1 that there are 3 steps. And this is what you need to be writing down in your foldable. Remember, you can pause it at any time so that you can write everything down. The first step is to move your ax term to the other side by either adding or subtracting it to both sides of the equation. Once you've moved your ax term to the other side of the equation, step 2 is divide everything by your b value. After you've divided everything by your b value, then you're going to graph the y-intercept and use the slope to find other points. Because once you've divided everything by b, you then have it in the slope-intercept form of y equals mx plus b. But wait, there's a method 2. On method 2, you find and graph the x and y intercepts. That's what goes in the box under method 2. Find and graph the x and y intercepts. You'll notice that your foldable says to find the x-intercept. Underneath that, you need to write this. To find the x-intercept, we plug in 0 for y, and then we get x by itself. In other words, we solve for x. Now, to find the y-intercept, you do just the opposite of what you do for an x-intercept. For the y-intercept, you plug in 0 for x. You'll notice that when it's the y-intercept, it's the opposite. Plug in 0 for x, not y. And then you get y by itself. In other words, you solve for y. When it was the x-intercept, you had to plug in 0 for y instead of x. All right, so let's actually put those steps into motion. If we have method 1 example, if you open up your pink foldable, it says you have 3x plus 5y equals 15 that they want you to graph. So the first thing we have to do is we have to rearrange this by getting rid of our ax term. In other words, moving our ax term to the other side. Remember, this is ax plus by equals c. We have to move ax to the other side. Since this is a positive 3x, we are going to subtract 3x. All right, so now over here on the left-hand side, we have 5y equals. Now, when we go to rewrite this, we always put our term that has our x first. So we'd say minus 3x plus 15, or a negative 3x plus 15. All right, so now we have 5y equals a negative 3x plus 15. Step 2 said to divide everything by your b value. What is our b value? Our b value is 5. So we are dividing everything by 5. Once we divide everything by 5, we get y equals a negative 3/5 x, because 3 will not divide by 5 evenly. And then we say 15 divided by 5, which gives us 3. So now we have the equation y equals a negative 3/5 x plus 3, and this is in our y equals mx plus b format. So now we can graph this using the steps that we did on the first foldable. So the first thing we have to do is we have to identify the y-intercept. When we have y equals mx plus b, our b is our y-intercept. So in this equation, our y-intercept is 3. So we go to our coordinate plane and we plot our y-intercept of 3. Next, we have to identify what our slope is. Our slope here is a negative 3/5. Since it's a negative 3/5, we started our y-intercept negative 3. That means we go down 3 since it's a negative. So we go 1, 2, 3 down, but we still run to the right 5 because 5 is positive. 1, 2, 3, 4, 5. Okay? And next, all we have to do is connect our points and draw our arrows. And we're done. So now let's try method 2. Method 2, first thing you do is find your x and y intercepts. So here we're going to find our x-intercept, and over here we're going to find our y-intercept. So make sure you write both of these equations and put x-intercept above one and y-intercept above the other. Okay, they told us to find the x-intercept. You plug in 0 for y. So we're going to say 3x plus 5 times 0 equals 15. Well, what is 5 times 0? It's 0. So we basically have 3x equals 15. Now we have to solve for x. What are we going to do to get x by itself? We are going to divide by 3. So here we get that x equals 5. That means our x-intercept is at 5. In other words, where it crosses the x-axis is at 5. Now we go over here to find the y-intercept. To find the y-intercept, we plug in 0 for x. So we'd say 3 times 0 plus 5y equals 15. We know that 3 times 0 is 0, so we are left with 5y equals 15. Now what do we do to get y by itself? We divide by 5 on both sides. So y is equal to 3. That means that this line crosses the y-axis at 3. Now we can go and graph this. So since our x-intercept is 5, we go to our x-axis and we find 5. 5 is right here, so we put a point there. Our y-intercept was at 3, so we go to our y-axis and we find 3, and we put a point there. So we have a point at 5 on our x-axis and at 3 on our y-axis. Now all we do is connect our points with a smooth line and draw our arrows, and voila, we are finished. If you compare your graph for method 1 with your graph for method 2, you'll see that the graphs are the same. You get the same answer, it's just two different methods of doing things when you have that equation in standard form versus slope-intercept form. So, I will see you in class on Friday, and I hope that we will practice this so that on Friday when you have to do it by yourself, that you will understand from the examples that we do in class. Have a good evening.